Hi everybody, welcome back to the next training session of SHL Technical Support Team. Today we continue with the remaining contents of the industrial oil chapter. The first is slideway oil. The slideway oil is applied for stable machine operation on sliding surfaces of machine tool, precision machine, industrial machine for lifting and transporting. Especially in the slideway system, a common problem is the phenomenon of sticking to the surface of the slide. The stick slip is caused by the friction between the metal and the metal due to the friction of the sliding surface. If the stick slip occurs, it will not be able to operate at a constant speed during the reciprocating motion of the machine tool, resulting in a decrease in productivity. Therefore, the first requirement when producing slideway oil is anti-stick slip, followed by the anti-wear ability to help stable movement, reduce friction and wear equipment when machining. In addition, it has oxidation stability because it is often exposed to friction and high temperatures to form carbon deposits that cause glue to peel off, heat up the machine and reduce power. And finally, good anti-rust to reduce the possibility of oil oxidation, reduce viscosity and oil life. Regarding turbine oil, steam and gas turbines are integral components of the global power generation industry. Steam turbines are motors with rotating elements which transform the energy of steam into mechanical work in one or more stages. To suit the needs of turbine makers and operators, the turbine oil must possess exceptional characteristics, particularly high oxidation stability. Long-term exposure to high-temperature steam, air inflow and oxidative conditions will form insoluble carbides. Followed by anti-rust because of easy to rust by incorporation of a water conditioning. Next, good anti-foam due to strongly stirred with air, resulting in bubbles in the oil surface and in the oil causing oxidation. And finally to demulsibility, when water is mixed, the oil-water layer must be separated quickly. Next, we will learn about machine oil. Machine oil is considered the most basic oil in industrial oils. It is applied to the machine part which performs relative motion such as machine tool, internal combustion engine vehicle, axle of the vehicle. Machine oils also need to meet factors to ensure quality when operating machinery such as viscosity, friction and wear characteristics and oxidation stability and finally anti-rust. Regarding compressor oil, there are two types of compressors, displacement compressors and dynamic compressors, turbo. The displacement compressor includes two types are piston and rotary. The piston type has been in common use for a long time, but today the traditional piston compressors have increasingly been replaced by the screw compressors. The reasons for this are the lightweight and compact dimensions of rotary compressors, low noise and vibration-free operation and their reliability. Therefore, the most commonly used compressor oil is for screw compressor. Focusing on screw compressor oil, the oil has a lubricating, sealing and cooling function. The lubricant is injected into the pressure chamber between the rotors. It then forms a hydrostatic and a hydrodynamic lubricating film. The oil, therefore, lubricate the meshing rotors and the plane and roller bearings which are part of the geared coupling. Furthermore, it seals the gaps between rotor and housing. The temperature of compressed air is adjusted by quantity of oil injected. Compressor oils have important service factors such as viscosity. It is necessary to select viscosity that can be completely lubricated considering the operating conditions such as discharge temperature and pressure. In addition, thermal and oxidation stability, demulsibility to ensure that the oil avoids delamination and oxidation by water, avoid causing rust and deposit formation in the system. Next is about vacuum pump oil. A vacuum pump is a device that removes gas molecules from a sealed space, creating a partial vacuum in the process. A vacuum pump's duty is to create a relative vacuum within a certain capacity. Vacuum pumps are classed as main pumps, booster pumps or secondary pumps based on their working pressure range. Because of the harsh operating environment, the vacuum pump oil is a high-quality, rust and oxidation-resistant oil that may be used in vacuum pump, hydraulic circulation lubrication system, compact air compressor and several other applications. It lubricates the pumping machine and collect impurities and moisture from evacuated systems at the same time. Vacuum pump oil's additive make it highly resistant to oxidation and offer it a longer service life than most standard oils. The essentials with vacuum pump oil are high viscosity index. The next is oxidation stability. Oil and equipment life are extended due to excellent oxidation and heat stability. About anti-wear. Additives and high-quality base oils reduce wear and increase the life of the equipment. In addition to being anti-foam, a special anti-foam ingredient encourages the speedy breakup of air bubbles, reducing entrainment and extending the life and performance of oil and equipment. Finally, we will learn about heat transfer oil. Let's take a brief look at the basic heat transfer system. First, oil will be heated and then go through the process that needs to be processed using heat. And when heated, oil will expand and increase in volume compared to the original temperature. So the oil will then be passed through an expansion tank containing the increased volume of oil when heated, because if the volume of the pipe is constant, the increased oil accumulation can rupture pipes and equipment due to excessive pressure in the closed system. Hot oil spills into open system. Finally, an expansion oil tank is placed on the top of the system, returning the oil to the storage tank when the temperature drops according to the free flow principle. Heat transfer oil is used in the system to transfer heat energy from the heat source to the area that needs heat, such as a textile system, a wood factory, a paper factory, etc. Heat transfer oil is divided into two. The main types are mineral and synthetic. About mineral heat transfer oil, which is a Group 3 base oil, capable of operating at temperatures from -10 degrees Celsius to 320 degrees Celsius, with a high flash point of up to 220 degrees Celsius, while the main component of synthetic oil is alkyl benzene, with operating from 20 degrees Celsius to 310 degrees Celsius and a lower flash point of about 180 degrees Celsius. However, the thermal and oxidation stability of mineral oils are lower than that of synthetic oils. Due to the composition of mineral oil, when continuously heated at high temperature, the carbon structure of the oil will fracture and form carbon deposits in the oil, causing system blockage. As for synthetic oils, due to the composition of alkyl benzene, the structure is more stable when subjected to high temperatures, so the possibility of deposit formation is much lower than mineral oil and easy to remove scale in the pipeline. Besides, the heating capacity of synthetic oil is better than that of mineral oil, low fuel consumption due to little change in total heat, economical due to excellent heat resistance and long replacement cycle, and mineral oil has poor thermal stability and short exchange cycles and high fuel consumption due to local sludge heating. Regarding heat transfer oil management, the first factor is viscosity. The viscosity must be guaranteed to change no more than 20% compared to the new oil. The cause of the change in viscosity is due to heating and oxidation. The second is about total acid number, below 0.3 mg Kali hydroxide, GAM, used to estimated the degree of oxidation and the corrosion of the device are accelerated when the value is increased. Regarding water content infiltrated into the system, make sure to be less than 360 ppm. If there is a large amount of water in the oil, it causes oil circulation failure, device corrosion, and oxidation of the emulsion. In terms of flash point, the change must be less than 10%, and millipore less than 50 mg, 100 ml. Due to high millipore, the heat degrades, leading to efficiency decrease, fuel consumption increase and clogged pipes. Above is the remaining content about industrial oil. Thank you all for listening. If you have any questions or concerns, you can contact the SHL technical support team via the email address below. Goodbye and see you again.